Hello all. Welcome to this interesting video on orbit equation. So, in this video, we'll try to derive the orbit equation in a very simple way. And this equation plays a very important role in determining the what type of orbit whether the planetary motion is being exhibited. Okay. So, all the conic equations what we have derived so far will be also applicable over here. So all the interrelationship also will try to discuss here. So you can learn with me, and if at all you require any uh, additional assistance, please let me know so that we can rewind and we can rework on that. So without wasting much time, let's get started. So here we have taken a ellipse, so which is at the center 0, 0 coordinate. Now, if you see here, this is the two strings I have drawn in green. So D1 and D2 represent the two strings. So if you know the property of ellipse, D1 bend D2 is going to be equal to the total major distance, that is the major axis distance 2a. So that we can already see from the property of ellipse. Okay. Now, if you see here, we have CF1 and CF2 is going to be my AE. So if you write here, the two dimensions, if you have CF1 and CF2, and that is going to be equal to CF2, which is going to be equal to A into E. Okay. Now all the dimensions we can write here. So B is my semi minor axis, semi minor axis. Okay. And AE is a distance from the foci or foci. So A is a distance from the foci. So foci, so which is equal to, that is your CF1 is equal to CF2, which is equal to A, which we have already know. We have written in the, just to write again for your better understanding. Okay. Now we have your x coordinate. So here we have something called the L. So L is called the semi-lattice vector. Okay. And here we have an x coordinate and a y coordinate. So here x coordinate value will be, so x coordinate value will be equal to A into E. And here y coordinate value is going to be equal to, coordinate value is going to be equal to L. Okay, from the geometry. And we'll take x and y coordinate as A and L. Okay, which is perfectly okay. Now I want you to recapitulate the similarity of triangles we have already studied in our 10th level or in the 8th standard level. So if you observe a similarity of triangles of two triangles, let's say we have a we have a similar triangles. Okay, similar triangles. Let's say we have A F1 C and A F2 C. Okay, if you write here AF1 divided by your D1 is going to be equal to AF2 divided by your D2. Okay, so that is the meaning of a similar triangles. Your AF1 divided by D1 is equal to AF2 divided by D2, because this substance center at 0, 0, which divides equal 50, 50. So this is going to be 90 and this is also going to be by 90. Okay, this is very evident from the geometry. Now if you see here, we are not sure about what is AF1 and AF2. Is it not? AF1 and AF2 is D1. So we made a mistake here. It should be AF1. Okay, let's do like this. You have AF1 and CF1 we can take, which will be okay. Okay, and AF2 divided by CF2. So I am extremely sorry, we have made a mistake here. Okay, so AF1 divided by CF1, we have AF1 and CF1, which is okay. And we go with the second triangle, AF2 and C, that is AF2 divided by CF2. Perfect. Now we have CF1 and CF2 here. So CF1 and CF2 we already know it is going to be AE. So both these two sides can be written as AF1 divided by AE, which is equal to AF2 divided by AE. Okay, now these two gentlemen can get cancelled off. Now you end up with AF1 is equal to AF2. So that means your D1, so which ultimately implies that your D1 is going to be equal to your D2. Okay, but we know as per the property of ellipse, your D1 plus D2 is going to be equal to 2 times A. It is the basic property of the ellipse. If you try to recall the basic conic section which you have studied in your elementary school, we have no. So you will be able to know that your basic property of ellipse. If a distance drawn from the focus, the sum of the two strings drawn from the focus is contributing me to it. So if D1 and D2 is going to be 2A, then probably I can write D1 plus D2, okay, is going to be equal to, or in fact there is not required any plus sign here, we can put directly equal to. Okay, so D1 and D2 is going to be equal to A. Why? Because your 2D1 is going to be 2A, so ultimately that gives me A. So this is how it gives. Okay, so D1 is going to be A, and similarly D2 is going to be give me an A value. I hope this is clear. Okay, so D1 plus D2 is equal to 2A, so that means D1 and D2 is going to be equal. So 2D1 or 2D2 is going to be 2A. So similarly, your D2 is going to be equal to A. So that means your D1 is equal to D2 is equal to A. So which is a perfect relation that we need to obtain. So this is also very important insight which we have derived from here. Okay. Now, I would like to recall once again the equation of the ellipse. If you know the equation of the ellipse, which is given by x square divided by a square plus y square divided by b square, which is going to be equal to 1 for ellipse at 0, 0 position. Now, let's say we have x is equal to, we already know x is going to be equal to a, and we have a y coordinate which is my semi-lattice vector L. Okay, so if you substitute the two values in this equation, what we are going to get is your a square e square divided by a square, okay, and y is actually your L square by b square, which is equal to 1. So if you simplify again, L square by b square is going to be equal to 1 minus of, here you have to be a bit tricky here, a square and a square get cancelled, you end up with only e square. Okay, you take e square in this side, so you end up with 1 minus of e square. Okay, that means your L square is equal to your b square into 1 minus of e square. That means your L can be a uh, plus or minus root of b square into 1 minus of e square, which is okay. But here what we need to do is like, we'll keep this one aside. We'll just write L square is equal to b square 1 minus of e square, which will be kept as still. Okay, but we want to use this equation somewhere else. Okay, so we know that from the geometry, if you see here, from the geometry, if you see the triangle A F2C or something, okay, in triangle AF2C, if you see here closely, this is going to be your base, that is AE, okay, and we'll square it off, okay, base square, and now we go with the altitude square, that is b square, which is going to be my D2. We already know D1 and D2 is going to be, we can write here also, it's fine, D1 and D2 is going to be my A. So that means your D2 is going to be my A square. Okay, here what we have done, we have just applied the Pythagoras theorem or the Bauthein's theorem. Okay, I think this is clear. Pythagoras theorem we have applied. Okay, Pythagoras theorem we have applied. So here in this case we can write your a square e square plus b square is going to be equal to a square. So now you do some simplification here. As b square is going to be equal to, you take a square common, minus of a square e square, and which is again equal to a square into 1 minus of e square. Okay. Now we have the b square equation here, and we have also obtained an equation like this: L square equal to b square into 1 minus of e square. Is it not? So I think things are pretty clear here. Now what we are supposed to do is, like, we know that your L square is equal to b square into 1 minus of e square. So we know your b square is equal to, we take this equation, we'll write it here, a square into 1 minus of e square. Okay, so that implies your L square is can be written as, what is b square here? It is nothing but a square into 1 minus of e square into 1 minus of e square, and you come up with L is equal to, we normally take plus or minus, but we are more interested about the positive region, so we go with the positive sign, and L is equal to a into 1 minus of e square. We get like this. And if you ask a question how, because it's just a simple math, you have L square is equal to a square into 1 minus of e square the whole square. And if you write L is equal to plus or minus, I don't want to put that because I'm interested with the positive value. So if you apply a root or something, you get a square into 1 minus of e square the whole square. And again, if you draw here, L is can be written as a into 1 minus of e square. So this is basically simple math. So that is what we have written here. Okay. Now, if you recall the previous work we have done, so we have the geometrical equation of a conic section, okay, which represents the orbit also. But if you want to do some more modification, that is going to yield me the orbit equation in a and e and theta format. So if you have r is equal to L divided by 1 plus e cos theta, we'll take plus here. Normally it is plus and minus, so we go with the plus sign here. So what is L here? So L we have already obtained. We know that L is going to be equal to a into 1 minus of e square. So we substitute that value here. So R is going to be equal to a into 1 minus of e square here divided by 1 plus e cos theta. So this is my orbit equation in terms of theta, e and a. Okay. Now if this is going to be my a circular orbit, then probably e is going to be 0 here. Okay, so you come up with r is equal to a, which is again valid. So this equation plays a very important role in determining the position of a planet at different orbital states, okay, for different varied angles of theta. So we'll try to know about theta and other stuff in the maybe in the preceding videos. I don't want to make it complicated in the initial stage itself, but we'll increase our concept bit by bit so that you'll be able to do it. I hope this is clear for you, and please try to work out from your end also. This is a very interesting part of your orbit equation, and we have derived also an orbit equation which is given by a into 1 minus of e square by 1 plus e cos theta. This is one form of your orbit equation in terms of a, e and theta form. Okay. And we have another equation also in terms of angular momentum and gravitational parameter, which we will see in the next section, the part 2 section of this orbit equation. So being said that, we'll wind up video here. So we'll wind up the session over here. So please try to work out, and we'll catch you in the next video then. Thank you so much.